Alrighty, so we are reaching to the end of this review. We're on question 17, but question 17 is very similar to the last question, 19. So what I'm going to do is page 8 or problem 18 first, and then do the graphs at the same time. It just kind of flows better. Simplify the following expression. Express your answer in simplest exponential form. So we're not going to reconvert that to radical form. Okay, so let's just start with the numerator. See what we can do with that, and then we'll look at the denominator after. Well, I see my 4 coefficient. There's not much I can do with that right now. X to the 6 over 3 times x to the 2 over 3. Well, we're working with common bases. So when you multiply with common bases, you add your exponents. 6/3 plus 2/3 is 8/3. So I have 4x to the 8/3. Now, as I'm writing this, now keep in mind, I'm writing upside down on a Chromebook with a stylus. Make sure your exponents really look like exponents. Okay, my 8/3 almost looked like I was multiplying it. Just be careful. In our denominator, we have to distribute power to a power. So this is 256 to the 3 over 4. And then power to a power, multiply 8/3 times 3/4. So that's 24 over 12, which is 2. So over here, I'm going to simplify 256. It's a 4th root raised to the 3rd power. So the 4th root of 256 is 4. 4 to the 4 is 256. So 4 to the 3rd is 64. So now come back over here. 4 over x to the 8/3, that's an 8/3, over 64 x squared. That's a really bad 8 on top. Now what we're going to do is divide our coefficients and subtract our exponents. 4 over 64, so 64 divided by 4 is 16. I'm going to put that on the bottom. If you want to do 1 over 16, you can. And then when you're subtracting or you're dividing exponents with common base, you subtract your exponents. So 8/3 minus 2 is 2 over 3. That would be 8/3 minus 6/3. Your bigger exponent's on top. So x to the 2/3 goes on the top. I would give you credit for that. It looks a little funky. A better way to write this is 1/16 x to the 2/3. Exponential form. If for some reason, since we are reviewing, they wanted you to write in radical form, it would look like this. 1 over 16, and you would write the cube root of x squared. This is simplest radical form. Now, this question is not asking for it, but just in case. Now, let's get back to those two graphs. I'm going to do the rest of this in the same video. Wow. So the Bucks just got a touchdown. What is it? 23-31. So let's do some math. What are they? Are they 8 points ahead? Yeah. 8 points in a football game. Anyway. For this one, we have to give the features of this graph. Question 17. What are the features of the function y equals 2 times 1/2 to the x minus 4? So I'm just going to write the features here because I really don't feel like scrolling up and down. Their word logarithm is not in this, so it is an exponential function. Because it's an exponential, it's got a horizontal asymptote. If it's a logarithmic, it's got a vertical asymptote. Since it's horizontal, it's a y equals, and let's look here. It looks like it's kind of leveling out at y equals -4. So it's y equals -4. Now, domains and ranges. I'm just reading the bottom of the paper here. So the range of the function, range is bottom to top. So our lowest y value is -4. And it doesn't get there. So it's around parentheses. And our highest y value is infinity. So that's the range. And it is decreasing. When you look for increasing or decreasing, you always look at your graph from left to right. It's going downhill. So it's decreasing. And then the domain, there's no restrictions on the domain. It was just that bottom part. Domain goes from left to right. So our domain is -infinity to infinity. A lot of people have trouble with knowing when the domain in the range -infinity to infinity, or if there's a number. If you have a horizontal asymptote, it's going to affect your range. If you have a vertical asymptote, it will affect your domain. And now we have to do the end behavior. Actually, I'm going to clear this because it's a big hot mess. So for end behavior, I'm going to start this, but then you'll see I'll erase some stuff. Not in this problem, but oops. Yeah, I will erase because I screwed up. So x is going to the left, and then x is going to the right. So when x is going to -infinity, that's the left. When x is going to +infinity, that's to the right. So as x is going to the left, the y is going up. So the y is going to +infinity. As x is going to the right, the y is not going to -infinity because it hits the asymptote. So the y is going towards -4. So that's why those values got circled there. So now our last question, number 19. So I know this is a logarithmic graph because it says log. So it's logarithmic. And because it's a logarithmic graph, it has a vertical asymptote. So sorry, my hand is getting shakier and shakier and shakier. And it looks like it runs into the invisible wall at x equals -3. So our asymptote is x equals -3. Now we're going to do our domains and ranges, and then I'll clear the page, and then we'll do our end behavior. So the domain, keep in mind, here's our asymptote. It cuts off the x. So our domain is not -infinity to infinity. It's -3 to infinity because that asymptote cut the domain off. In our previous problem, it was a horizontal asymptote, so it affected the range. Vertical asymptote is x equals, it affects the domain. The range has no limits, -infinity to infinity. If this is something that's difficult for you, go to Delta Math and do the problems towards the end of the review where you get to practice this. That's the only way it's going to get easier. So now our last one is the end behavior. So we've got our domain from before is -3 to infinity. Our range is all real numbers, -infinity to infinity. So now our end behavior, and this is where I'm going to do some erasing. Normally you'd say as x goes to -infinity and as x goes to +infinity. But in this case, we can't go to -infinity on the x because our domain ends at -3. So as x goes to -3, now let's see what the y is doing. So as x is going to the left, the y value is going down. So y goes to -infinity. And the last part, as x goes to the right, it's a very slow climb, but the y is also going towards infinity. I hope this is helpful. Again, if you have questions, email your teacher and get the help that you need. Good luck, guys.